Welcome everyone. So in our previous video, we talked about the pseudocode. We explained what is pseudocode, the benefits of pseudocode, right? And in this video, we are going to talk about the flowcharts. We will also talk about what is flowchart, the benefits of flowchart. Then we are going to do a short summary of the algorithm. Okay, so let's get started. First of all, what is a flowchart? Okay, so the flowcharts, they are basically the graphical representations of a program's algorithm. The pseudocodes are the textual representation of the program's algorithm, while the flowcharts are the graphical representations of the program's algorithm. Okay, and why we should use this graphical representations of programs algorithm? While the flowcharts, they use different shapes and arrows to illustrate the sequence of steps and decision points within the system. Okay, it helps us to visualizing and understanding the logical flow and the structures of a program, which makes it easier makes it easier to analyze and troubleshoot the problem. Okay, and each shapes that are being used in the flowcharts represents a specific action, and the arrows that you see in the flowcharts, it indicates the direction of the flow. Okay, so the flowcharts, they are widely used in the problem solvings due to those benefits. Okay. And in our previous video, we stated that the pseudocode, it offers a textual description of the algorithm steps, right? For example, here's the pseudocode of a task. So what if I apply the flowcharts to the same exact task? What would my flowcharts would look like? Here's what it would look like. Okay. This is the flowchart. First, it has a shape for the beginning. And then there's another different shape for reading the user input. Okay, each different shape is representing a different action. And as for the processes, if there is a process, we also have different shape to describe the process in the flowchart. Okay, and then we have another shape for the decision. And then we have a different shape for the input or outputs based on the decision. Okay. And then lastly, we have the shape that we give at the beginning, which is also representing the end. Okay. So this is how what it would look like if we use flowchart to the same exact task. See, pseudocode is the textual description of the algorithm steps. And the flowchart, it is the visual representation of the pseudocode structure. Okay. And why we should use those different shapes in this flowcharts? Why we should go with the flowchart? What benefits the flowchart is going to give us? So the flowcharts, it help a programmer to better plan and analyze the structure and behavior of their codes. That's the main benefits of the flowchart. So flowcharts are used for several purposes in programming, which includes planning, okay, analysis, and communication, and documentations. Why it's used for planning? Because flowcharts help the programmers to plan out the logical steps of their program before even writing any codes. Okay, which improves the efficiency of their coding, and it also saves time. And analysis. So the flowcharts can be used for analyzing the existing program to identify the bugs or any other problems or any other areas for the improvements. Okay, that's the benefit that the flowchart is going to give to the programmers. And as for the communication, the flow chart can be used to communicate the structure and behavior of the program to another programmers or users, which makes it easier for them to understand how the program works. Okay, communicating is also extremely important for the programmers. And lastly, it is the documentation. Okay, flowcharts can be used as part of a program's documentation, because it provides the clear guidance, clear summary of the program's logic and structure for the future references. Okay, so those are the reason why we should use the flowcharts. Okay, and here are the different charts that are being used. Different shapes that are being used in the flowcharts. We have this oval, which represents the starting and ending points. This is the symbol of oval shape. And now we have the arrow or flow line, it's called. Basically, it's the connector that shows the direction of the flow. In order to show the direction of the flow, we do use this arrow or the flow line. Okay, and then we have parallelogram, represents the input and outputs. If there is any input data that needs to be read, or if there's any output data that needs to be displayed, we use this parallelogram shape in the flowcharts. Okay, and then we have this rectangle next, which represents the process. If there's any steps that is processing, we use this rectangle to describe that step. Okay, and then you have this diamond, a diamond shape, which indicates a decision. Okay, so if there's any decision making that will be involved in the step, then we use this diamond shape. Okay, such as if statements, for example. And then lastly we have the trapezoid. The trapezoid, it basically shows a user to enter the information enter the information that's needed or data manually. Whenever the user needs to provide information or any data manually, we can use this shape to describe that step. Okay, each of the shapes, they do have different meaning. They are used for different actions. And here are also some of the tools that are using flowcharts more often. There are some of the tools, flowchart maker tools. The most popular ones are the PowerPoints and Keynotes, and we also have SmartDraw, and we also have some other tools that we can use to make the flowcharts. Okay. And now let's take a look into some of those tasks that we previously have completed with the pseudocode. In our previous video, we did write the pseudocode for converting the Celsius to the Fahrenheit. And what if I give the flowcharts this time? What it would look like? So in order to give the flowcharts, first we need to begin the task, right? So to begin the task, I will use this oval, this shape, oval. Okay? So the task is started. And then I still have to use the arrow to point out the direction of the flow. And then next, I need to read the input from the user. Okay? So if there is an input that you need to read from the user, if we need to ask the user to manually enter the input, then I have to use this shape, which is trapezoid. Okay? So the trapezoid, it basically shows the user to enter the information or data manually. This time, user has to enter the number of Celsius manually. That's why we are using this trapezoid in this flowchart. Okay, and after user enters the information manually, next step we have the processing, right? Which is converting the Celsius that user entered to the Fahrenheit. It's called processing. And for processing, we use the rectangle. This rectangle shape in the flowcharts, it represents the processing step. Okay. And after processing it, next we need to display. Okay? We need to give the output, right? So if you want to give the output, then you will use parallelogram. The parallelogram is it is the one that represents the input or the output. Okay? And then lastly, it is going to end. So as for the end, for the starting and the ending, we use the same shape, oval. So this is the flow chart of this particular task. Okay, and in our previous video, we also did the pseudocode for odd or even this task. So we needed to ask the user to enter the number. Then we have to make a decision of whether the user entered number is odd or even. Then we have to display the output at the end. Okay, so we have completed this pseudocode for this task. This time, let's do the flow chart for this particular task. Okay, so first it is begin. We use oval. The oval is for the begin and ending. Okay, and then after the next we need to read the number. Okay, so we need to ask the user to manually enter data, which means you will use this shape, which is trapezoid. Okay, oval and then the trapezoid. That means it started and then it asks the user to enter the number. Once user enters the number, then we have a decision to make. Okay, we need to make we need to create a condition to check whether this number is odd or even. Okay, so if this number is even, then the output should be even. Okay, see, for the output we do have this parallelogram. Okay, parallelogram can be used for displaying the output. So if this condition is evaluated to false, that means it is odd number. But if it is evaluated to true, that means it is even number. So two different outputs, two possible outputs that we need to display. That's why we have two parallelograms. Okay, so only one of them will be displayed. Which one will be displayed will be based on this decision. That's the condition of this decision here. Okay, and then once it's displayed, next we can end the task. So to specify the ending, we still use the same shape. See, this shape, oval, it is used for beginning and ending. And then we have this trapezoid, which is used for manually getting the user input. And then we have this diamond shape, it is for the decision. And to display the outputs, we have the parallelogram. Okay. And here's one more task, the last task for the flowchart. So the same task that we have completed in our previous video, finding the sum of n numbers until the user quits. Okay, so this is how the flowchart of this task would look like. We began it first by using this oval shape, and then we have the rectangle, which is representing the process, and then we have the trapezoid, okay, which is for manually getting the data. And then we have another rectangle, which is a process, representing a process, okay? And then we have this diamond, which is for the decision. If the answer is no, if the user is not going to quit, that means we go back to this step, which is reading the number. But if the user entered answer is yes, then we just print the sum at the end, okay? So this is the flowchart of this third task. All right, so here is the difference between the flowchart and pseudocode. As you can see, flowchart, it is basically the pictorial representation of an algorithm, while the pseudocode is the text-based representation of the algorithm. And flowchart, it is much detail can be much detail can make the flowcharts complex. If you add much details into the flowchart, it becomes more and more complex. But you will not see this problem with the pseudocode. Pseudocode is flexible for adding any details. Okay, and then the modification. So it is hard to modify the flowcharts because its structure resists the modification. But with the pseudocode, it is easier to modify. Okay, and structure. The list of specific elements used to create the flowcharts. The list of specific elements are used to create the flowcharts, such as those shapes that you see earlier. And as for the pseudocode, no standards or tools are required. But for the flowcharts, yes, you do have to use some certain tools in order to give those charts. But for the pseudocode, you just need to give the texture-based. You just need to describe it with the textual value. Okay, and in terms of understanding, the flowcharts are easier to understand, but pseudocodes are difficult to understand in terms of understanding. Okay, and the beneficial flowcharts are more beneficial for the smaller code because you don't want to include so many different types of shapes in one task. Okay, but pseudocodes, they are beneficial for larger programming codes. When you have larger programming codes with so many requirements, it's better to go with the pseudocode. Okay, so here are a few key takeaways from this module. So make sure that you know that algorithm is a step-by-step procedure or a set of rules for solving a problem or specific task. An algorithm should be well-defined and specifying exactly what needs to be done at each of the steps. Okay. An algorithm can be represented in the various ways. It can be represented in natural language. It can be represented in pseudocode, flowcharts, or even in an actual programming code. Okay? And flowcharts, they are not specific to any particular programming language or to the platform. Okay? Thank you so much, everyone. I will see you all in the next video.